Hello and welcome. This presentation is the second in a series of webinars brought to you by the Institution of Analysts and Programmers. The IAP is the leading professional body for those engaged in the production of software. Our goal is to improve software for society. Today, we will be presenting the topic of architecture state modeling, or ASM. Modeling is important as it enables multiple architecture states to be understood, planned and managed. My name is Paul Lynham. I'm a fellow and the president of the Institution of Analysts and Programmers. I'm a freelance software consultant working on the production of quality software systems. I would like to introduce you now to my good friend and colleague, Matt Thomas.
Thank you, Paul. Yes, indeed, both friend and colleague. I'd like to just reflect. Paul and I met at the NHS Wales Informatics Service, where we're both in service in a similar capacity in the architecture team. Other similarities between us, well, we've both risen through the ranks, or what some might say not risen, sunk, from software engineering to architecture and enterprise architecture. We've both enjoyed actually talking a lot about compiling, which is something that Paul presented last time, and also how to build in quality to the engineering process. And one of the things, what we're presenting today, architecture state modeling, is a culmination of years of thinking about architecture state modeling from looking at TOGAF and what it's trying to achieve there, and the confluence of that and looking at object orientism and also Paul's ideas about compiling and how those things might come together. So that's basically what was the initiation of this presentation today.
Lovely, thank you, Matt. Our presentation today will look at this topic through three parts. First, we will look at the purpose of ASM, why we want to change our current system, what our baseline and target architectures, and what we may encounter on the roadmap, keeping a scorecard along the way. Then we will look at the method used in ASM and the rationale for it. We will cover our idea of fuse principles using ideas from both OOAD and TOGAF before looking at model organization and who does what. Finally, we will reflect upon what we've covered with a summary and then have a Q&A session. So please save your questions until the end. So what is your scorecard? Along our journey, we will keep a scorecard by answering a few questions. And the answers to these questions will help with self-awareness of your current situation. So the questions are, do you want to bring about significant change to a complex architecture? Can you show me a clear picture of the current architecture? Can you show me a clear idea of what it is to become and why this target architecture is going to bring benefits? And can you show me the full roadmap from current to future architecture with the risks, actions, issues, and decisions involved? Ultimately, what do you want to rely upon in order to answer these questions? A crystal ball or perhaps a methodology? So, do you want to bring about a significant change to a complex architecture? On the left, you can see a rat's nest. It's very complex and very arduous to understand. Our aim is to reduce complexity. We want this to be comprehensible, not complicated. If you've seen the previous presentation or read articles on compiling code, you will know that we can assess software using three properties. These are comprehensible, appealing, and compelling. Comprehensible really means understandable, And it's got to reach that level before you can put your first foot on the rung of a ladder. You've got to be able to understand whatever's in front of you, whether it's code or whether it's a design. Appealing means that it's attractive and well structured. And compelling means that it's persuasive, that you believe that this is going to work. So this idea applies to quality engineering in general. We can move from a congealed design to a compelling design. So from a rat's nest on the left to service-oriented architecture on the right. Can you show me a clear picture of the current architecture? Well, before committing to a journey towards our target architecture, we should be sure of where we currently are. Do we have any existing documentation? If so, there could be holes and errors in the documentation of the current state. Is it always kept up to date to reflect the true state? Without a true picture, how can you answer the question, what are you changing and what's wrong with it? We may have a glimpse of the future, but what are the issues and risks of keeping the existing state? What are our motivations for change? Can you show me a clear idea of what you want and the benefits? So what is the motivation for this change? Can you state a clear idea of what you want and what the benefits are? Well, you could look at this under different categories such as time, cost, maintainability, manageability, and sustainability. Can you show me the full roadmap? So remember this idea of a scorecard. This is a question we need to answer. RAID analysis, that's R-A-I-D, is a project planning technique for identifying key project concerns. These are risks, which is the R, assumptions, the A, issues I, and dependencies, D. And project teams should complete an initial analysis at the beginning of the project and then monitor the issues via a RAID log. On each step along our journey from our baseline architecture to our target architecture, there may be different choices. So we've got the decisions to make. You may come across bear traps, that's a risk. Note the assumptions, find issues such as a roadblock, and of several dependencies. So this technique allows you to act swiftly and decisively to deal with any risks or issues identified. You can check your assumptions are valid and you can understand your dependencies and the decisions that you've made. Going back to our scorecard, we asked these questions to find out where we were. Do you want to bring about significant change to a complex architecture? Can you show me a clear picture of the current architecture? Can you show me a clear idea of what you want it to become and why this target architecture is going to bring benefits? And can you show me the full roadmap from current to future architecture with the risks, actions, issues, and decisions involved? So do you want to, again, rely on this crystal ball, or would you prefer a methodology? Well, I'm now going to hand you over to Matt, who will go through the methodology.
Thank you, Paul. Yes, I'm afraid I don't have any crystal balls to hand out this afternoon. So we're going to have to focus in on the methodology side. A foundation piece of this is understanding what different types of architecture state can exist. And the obvious one is the current architecture. Everything has an a current architecture, the as is, often that's confused with the baseline architecture, which isn't necessarily the case. I'll touch on that a little later. But we also have a number of future architecture types that we can think about. Let's go to the ultimate one. If you ever do arrive at a target ultimate one, the target architecture, where you want to go. But of course, in going from a rat's nest to a service-oriented architecture, you're not going to do it in one go. You will need transition architectures, plural. So that's where this comes into play. So transition architectures are often transitioning from your current architecture on your way to your target architecture. The candidate architecture, again, it's a future possible architecture, one that hasn't yet been chosen. It's a planning technique, really, to determine what your target architecture might look like. So if you have a number of candidates and you choose between them, then the one you choose will be your target architecture. And similarly, if you're thinking about a journey from current architecture to target architecture, you will need candidates for your transition, because there are going to be different ways to go from A to Z, and some will be better than others. Now, so that covers off really the architectures. We've been talking about roadmaps as well. Now, the roadmap will, again, that will comprise your current architecture at the beginning. It'll comprise the transition architectures along the way, and then your target architectures. Of course, the roadmap doesn't involve a candidate architecture, not the chosen roadmap, but you could have looked at a number of different roadmaps with candidate architectures along the way. All of that diagram embodies that information. I mentioned baseline architecture, and that's where I'll then mention this relationship down here. The idea of modeling more than one state at a time when it's hard enough to model one. Why? Well, we'll get on to why, but in more detail, but primarily, fundamentally, it's so that you can draw a comparison. And as I say, we'll get on to that. Now, what are you drawing a comparison against? It's from an architecture, any one of these, to a baseline. So let's progress and see what that looks like. There's some text for take home and review at a later point. And let's move on to the rationale. Why would we go to the bother of modeling more than one architecture state when it is actually difficult enough to model one? Well, it's so that we can actually control what we're trying to do, so that we can answer such questions as, if we're looking at candidate architectures, how do we assess them? Which of them has most utility? Which is at least cost? Which fits our time frame? And the summation of those, and other criteria as well. If we have design principles, which of our candidate architectures are more in keeping with our design principles? Then, if we're actually setting out on the journey, what is involved in going from A to Z? If you can make the comparison between the states, you have a basis upon which you can do the migration planning, upon which you can say, in my first step, this is the work involved. In my second step, this is the work involved. And equally, the flip side of that is, as you're doing the work, how far progressed are we? Have we advanced to between states B and C, 50%, 100%, you know, and where are we on budget? So again, it's about controlling your work as an organization. And finally, in reflecting back from Z, where you've arrived, of course, that's going to be a changing picture, isn't it? But in arriving at a destination and looking back at A, where you were, one can look at the measurable benefits of the improved architecture. There's another rationale I haven't put on screen, but it's very similar to the roadmap piece, and that is, product variance. Product variance. So if you've got a software architecture where actually you've created a number of variants, you might want to look at, so for customer X and for customer Y, we're doing different things. how much is different out of necessity and how much is different because we haven't got the best reuse. So being able to do analysis of different variants is another application of this technique. So Paul used the expression fused principles, which came out of a conversation we had walking around the park before lockdown. Now, what principles are we using here? Well, TOGAF talks about architecture building blocks and having a building block library. So that's the building block library here, and it's containing architecture building blocks. It also talks about solution building blocks. Well, and it talks about the architecture state, well, making instances from the building block library, and therefore that the architecture state comprises solution building blocks, and it also naturally needs to comprise the relationships that exist between them. But what principles are we fusing here? We're fusing that with the principle of object-oriented design. It's the same thing. We're saying that building block library is like your class library. This is a good way to understand it if you come from a software engineering background. It's a class library, and your ABBs are classes, and your SBBs are merely I say merely. Actually, this is where they come to life. They're instances of your architecture building blocks. And it is the relationships that they have with one another and how they play together that bring about the behavior of your architecture. So that's the principle is being fused and then applied in the modeling environment. So once again, some take-home text. I should have animated that in paragraph fashion, but it's there for you for future reference. What does that look like? So we're looking here at what I think is one of the best modeling tools that certainly I've come across and I've used a lot. This is the Enterprise Architect browser. And what we see in Enterprise Architect is we've got the architecture building blocks library. It's separated into the architecture domains. And then we have an area where we do some work. And in this case, it's for retail pharmacy. And you see the architecture states listed in underneath that area of work. So the hierarchy, the organization really is keep your library in one place and build alongside it so that your solution building blocks go in the architecture states. And again, same pattern. The text will be there to review later. So what does that look like again in another way, looking at it sort of visually? In our example here, we've got retail pharmacy. We've got in our case study, and we'll demonstrate some of this shortly. We've got architecture states for normality, where we have face-to-face retail pharmacy, as we had been accustomed to. Then the next state from that was lockdown, wasn't it, for pretty much everybody? And you see that was marked at a point in time as the current state. It's arguable about whether that's the case now. Retail pharmacy with special measures to reduce the risk of spreading coronavirus. But looking beyond that in the roadmap is this organization who's been shunted into this transformation needs to look beyond, and what are we going to do about it? So they're modeling the new normal, which is retail pharmacy with preventative measures and resilience to future outbreaks. And of course, these relationships, the next state shows you your roadmap, but the prior state is a way of drawing a comparison from one state to any prior state. So notice that this isn't previous state, it is prior state, a prior state. Right, so that sets the scene for the example. The question that most people ask at this point is, who does what? Have we got Paul?
Yes, that's great, Matt. Okay, so you've just shown us the example of a transformation to retail pharmacy brought on by COVID, taking us from normality to lockdown, and now we're considering the shape of the new normal. So, as an enterprise architect, I want to visualize my transformation roadmap and carry out gap analysis. Can you show us how to do this?
I certainly will give my best shot. So we're going to switch to a model I prepared earlier, as we discussed. I hope you can all see it now. Essentially, this scenario, it's not unlike the diagram that was depicted in the presentation. I'm going to show you basically how to build one of these. We've already got 3 states. Let's add a 4th one. And from the toolbar, I'm going to add something called 4. I'm just going to give it that. I'm going to call it settled state, because the new normal is what we've got now, and it's actually quite unsettled, isn't it? So there it is. And what I need to be able to do then is say that that'll be the next state from the new normal. So that's how you do it. It seems very straightforward. Well, the devil's in the detail. The devil is in what do you, sorry, this is the wrong piece of the model. Where is it? Here. The devil is in what you put inside the architecture states here. I'm even losing my own way. So these, it's the content of the architecture states. Now, that takes some time to build up, and no demo could hope to achieve that. But what it will show is you see that I've got these architecture states already modeled, and I've got some model content. The rationale I gave for doing this is to be able to draw comparisons. So let's see how you do that. So what we've got here is a dashboard for the gap analysis, and I'm going to plunge straight into gap elements. What are the gaps between aspects of your architecture, between the different states of your architecture? Well, the first thing that we're shown is a summary, and in the total roadmap, what we're seeing is 15.5% of elements have been added as they've been progressed. 1% have been eliminated, and 83.5%, the majority remain the same. What does that mean in more detail? Well, if I edit this view here, and I'll just roll things up so you can see a little bit, see the wood for the trees initially, and then I'll expand things out as we go. So essentially, we've got a view on our model content. It's a real-time view, so if you change the content, the view will change. And it's showing you that from normality to in lockdown, there'll be some elements that have been added, and there'll be some elements that are unchanged, the no gap ones. Similarly, from normality all the way to the new normal, similarly from in lockdown to the new normal, and then from settled state to the new normal, we'll also have some content. So what does that look like? If we go into one of them, it's going to be most interesting here. I think this one. So in lockdown to the new normal. Let's see what's been added. Essentially, a set of requirements and use cases in this particular model. It would apply the same for any model content, whether it's components or your classes, your data, whatever you would like. So it's showing that we've added a requirement in the new normal to auto-populate the pharmacy store basket, to check prescriptions, to use contactless payments, to use prepaid payments, and to log the track and trace details to help the wider initiative. So those are some of the things that have been selected by the organization as the things to do next in the new normal. Similarly, there's been something that's been removed. So registering a new patient, interesting. There must be another solution for that then. And the remainder are, there's no gaps whatsoever. So it's a small, but probably important to this organization's change. And how I use this is I can right click on it. I can find, let's find it in diagrams. I don't know where this is going to take me, but let's find it. You can see where this is used in your model. So here we've got the registry of requirements. So I'll come out of that one. If we look at that use case, find that in diagrams, We can see that used on a use case diagram. So not only does it provide a way of comparing your architecture states, it also allows you to navigate around them. So I'm conscious of time. I could go on a lot more about that. So we'll just pull back to the presentation for now.
That's fantastic, Matt. So that makes it possible to do gap analysis between multiple architecture states. I like it. I can see that would be of great value and would also apply to gap analysis of candidate architectures.
Indeed, yeah.
Yeah. Now, let's say if I'm a solutions architect and I need to model a new CRM and we don't have a building block defined for it, how would we do that?
How would we do that? Okay. That's good. Thank you for that question. It's also an opportunity, before I get straight on to answering the question, of showing you a little bit about the magic about how we achieve the gap analysis. And then I will directly answer the question, if you'll indulge me. So I'll show a building block that's already been created, and I will show an instance of a building block that's already been created. So that's going back to that slide I showed earlier, the magic under the hood, that fusion of principles. And I'll show you what's going on. So essentially, on this diagram, we've got an enterprise resource planning system, and we'll see that this one is actually living inside the architecture building blocks, applications, and logical application components. I'll prove that by showing you where it exists in the browser. And there we are, it pops up in the browser. So it's up here in our building block library. You'll notice on the right, though, there's something else here. There's a traceability view, and this shows that it is a classifier of something, ERP. So we've made an instance of ERP. Guess where it is? It's actually sitting on this diagram. I'll show you now. Find it all diagrams, open, and there it is. So essentially, that's the way in which we have a relationship between the building block library and the architecture states, whilst keeping the building block library pure and not muddying the waters of the architecture state. The architecture state is entirely within its own bounds, but the tool is aware of the fact that the provenance of the instances, that they were made out of the templates. And that's the bit that allows you to then compare from one to another. So having told you that, I'll now show you what I need to do in order to create a new CRM component. So I've got my TOGAF architecture content model toolbar, sorry, and I simply add a new element. It simply is. I wasn't going to respond then for a bit. And I will call it customer relationship management system. And to be fair to it, so that other people coming along will be able to understand the purpose of this building block, I will give it a description, one I made earlier. And I'll say that it's a system for recording and retrieving contacts with customers in order to build up a picture of the customer's preferences and requirements. So it defines the role of this building block. So I've created it, and that's all very well, and it exists in our library, but I haven't yet, Solution Architect's not done anything with it yet. So what did we say they wanted to do? They wanted to be able to create an instance of it in the candidate architecture. Very well, let's do that. So what we do is we drag from the building block library onto a diagram that sits in your in the space of the candidate architecture, and you make it into an instance, and you give it a short name, CRM. And from this point on, I'm able to start drawing associations or communications, or model the logical interactions between these solution building blocks, and similarly for detection system and so on. So now I'm freely able to build up an architecture state from solution building blocks, However, if you look at the customer relationship, it itself only has that single relationship. It's kept pure. It can be there to be used for other architecture states, and that way it acts as a single source of the truth for all time. So there we are. Hopefully that answered the question with sufficient clarity.
Yes, indeed, Matt. If I was a data architect in a greenfield project, then I wanted to create a conceptual data model for my enterprise, how would I do that?
Okay, I mean this is an interesting scenario for me. So data architect. Greenfield implies that there's no starting point. We don't have anything really in our building block library. And you'll forgive me because I jumped ahead a little bit actually, and created a couple. So essentially, just pull up the right toolbar for this. Essentially, the way I see it is that the data architect's going to want to start thinking quite freely in terms of the concepts that they're dealing with, the data concepts. And this is where populating there's an opportunity, I think, to populate the building block library fairly freely, and then go on to make instances of them and join them up. So let's go by example. So conceptual model 1, I want to, as I said, data architects the first thing they're going to want to do, I think, is sorry, 1 second, architecture content model, is to start putting in a whole bunch of concepts. They're thinking quite freely. So this is concept C, and this is next one's concept B. Please mind the spelling. Forgive the spelling. I'm aware of the time. Build them up, but not link them up yet. Then, when it comes to thinking about the different ways these concepts relate to one another, I think the data architect has got quite a task ahead of them, much more onerous than thinking of the concepts in the first place. It's the connections that are the key thing here. So they've got now the opportunity to put together a number of candidates of the conceptual model. So they'll bring all these concepts onto the diagram. Oops, that's a link. My mistake. I'm rushing too much. Get rid of that. Make them as links. Sorry, as instances. Select for all. So I've now created one view of the world that, oops, beg your pardon, just do a quick link between them. So I'm just going to put a simple association on there. Won't start naming it. The data architect would. They want to put meaning to all of that. And that's different to, if I do this now, go to concept 2 and drag the same set onto this diagram. I missed one in the previous attempt, but it could equally have been all of them, and build up a different relationship set. And then they can reflect and they can do the comparison between them, and not feel that they have to necessarily throw one away before doing the other one. And therefore, I think it's a quicker way of arriving at the conceptual data model that they understand and they can communicate with other people, and the other people would agree to as well. So similar approach, but for the data architect.
That was great, Matt. Excellent. As a chief architect, I want to ensure good governance of the ABBs in the library and the SBBs made use in them. Could you briefly tell me how you do that?
Thank you, Paul. Yeah, I think this is a real key piece, actually, the governance piece. Now, the benefit of using a modeling tool is a lot of the automation that you get. And much of what you've seen today is based on that automation. And the automation hinges off data, the data that surrounds the model elements. When you create a model element, let's look at concept, the misspelt C Pongcep D. When we look at that, we see that it's created with the status of proposed, and it also says the author. Now, a chief architect doesn't want to browse through the model all the time and look for those that are a status proposed. They want a real-time view, really, don't they, of those that have come along and been proposed. And this is where they can do it. Essentially, it's a model view. It looks through the architecture repository. It looks at the architecture building blocks that are approved and proposed. So let's actually get in and work with this thing. We'd be less concerned with the ones that are approved if it wasn't for the fact that you've got solution building blocks that are proposed from them. So we've got approved building blocks. We're happy with those. They're signed off as being legitimate templates to hold in your library, out of which you can create the instances, the solution building blocks. And now we've got some components here that have been added, and they're now only in the proposed state. So the chief architect can have a look at those and go, or other stakeholders as well can look at those and go, okay, that's been proposed, but is it right? And come up with, but through working with colleagues, we'll come up with the right answer to that question. I'm not going to prejudge what it is. Now, when it comes to architecture build, this is where the chief architect really gets involved. When you look at proposed architecture building blocks, so anything that's gone into the repository that's proposed, you can have a look at it as a chief architect. You can look to see where it's been used, and you can look to see who was the author. In this case, Paul, you authored the pharmacist here. Chief architect would have a word with you. They'd say, okay, how are you using it? Why are you using it? And basically have that discussion, and they could work their way through the model as well and say, right, yeah, the pharmacist is involved in this use case here, and that way, there's by regularly checking in to those that are of new proposed status, the discussions that need to be had can be had.
Oh, that was very comprehensive. Thanks, Matt. Lastly, as a junior architect, I want to build my first model. What sort of sticking points could I have?
Right. Yeah. I think confidence is the biggest one. Quite simply because one might have been shown how to use the tool, and maybe if you've already been using a tool to build up one architecture, that's difficult enough, and now all of a sudden you're being thrust upon you this challenge of multiple architectures. Well, the answer is the same as with the chief architect, actually, in that by providing visibility to others that of your proposed model, the discussions can be had. It's the flip side of the coin, and that way, that's the quickest way to learn. And by freeing up a junior architect to say, work on a candidate architecture over there, draw a comparison to other candidate architectures that a different architect is working on as well, because you do want to get different thoughts and compare them. They're free to experiment. I'm not going to say make mistakes, because we all do that. But they're free and empowered to experiment and do that with oversight provided by other members in the team.
Oh, that's great. Thanks, Matt. Could you summarize then?
Yeah, thank you, Paul. So it's all about change. I mean, everything is all about change, really. But architecture work is about change. It's about going from A to Z. And if you're going to do this, Z must actually improve upon A. You want to be sure that it will, or modeling will enable you to choose a different Z before you start. And the other thing is, it's going to be a journey, isn't it? So the highway to Z shouldn't be through unmitigated hell. But if you are going through hell, keep going. Don't stay there, and make sure you're well armed. Have a tool, have a methodology that's going to help get you through it.
Oh, that's great. Thanks, Matt. This presentation was brought to you by the Institution of Analysts and Programmers, the leading professional body for those engaged in the production of software. Our goal is to improve software for society. If any of you have a topic you would like to present, please get in touch with us. And now we'll open up for questions.